Okay, so this is the first lesson of Unit 4. And Unit 4 starts out where it's more rules and not a whole lot of math. So let's talk about some vocabulary here. So all of Unit 4 is going to be about polynomials. So what you need to know is the root term poly means many. And you know, you've studied this in your Bible classes when you talk about polytheism. Well, this is just polynomials, so many terms. If we have a monomial, this just means we have one term. And so one term would be something like x, or it could be 5, or it could actually even be x squared, right? So all of these would be one term if they were not all added together or subtracted together, okay? So a monomial would have one term. A binomial has two terms. Think about bicycle. A trinomial, tricycle, has 3 terms. But a polynomial is going to have more than 3 terms. Actually, all of these are going to be polynomials. These are just special types of polynomials, okay? So when we look at a polynomial like this, we see we've got a bunch of different terms. So vocabulary here. What we're going to say is that this one right here, let me change my color. This one right here would be to the 5th degree. And this would be to the 4th degree and the 3rd degree. And what we're doing when we do this is we're looking at the power on the exponent. Okay, so the degree of the polynomial, if I keep going here, this would be second, this would be first, and this would actually be the 0. And here's what I know. If I have 5x to the 0, what we know is that anything to the 0 power is 1. And so this, we could say that this x to the 0 power goes away, and that's why we have just 5. So we actually have a power here. The power just happens to be 0, all right? So the degree of this polynomial is the 5th degree, and this is the biggest power on my exponent, all right? So I have 1, 2, 3, 4, 5, 6 terms. 1, 2, 3, 4, 5, 6. So let me actually do this right. So this is terms. So this has 6 terms because I count this 0 term right here, and the degree of the polynomial would be the 5th degree. Now, we can also say that this has the 5th power or degree. Either power or degree are going to be interchangeable, okay? Leading coefficient. The leading coefficient is always the number in front of the biggest power. Or we could say the highest degree. All right, so the goal here with what we're doing with polynomial functions is we are going to graph a polynomial function, so something that looks as crazy as this, without putting it in a calculator. So to do that, we've got some rules, and that's what this is. This is end behavior guidelines. So let me talk for just a minute about what end behavior really means. So if I was to draw a graph, any kind of graph, and I have something that goes like this, for example, my end behavior is what's going on clear out here. It's actually, even if I go even further, it's way out here at the negative infinity in the x direction. And this graph is going to keep going and going and going, and it's going to go to the positive infinity in the x direction. So what we're doing when we look at end behavior is we want to know what's happening way out here. And what you're going to find is a lot of times we're going to have things happening here in the middle that have nothing to do or are going to contradict some of our terms for what's happening at the end. So end behavior is the key here. What's happening way out in the end, if you think about this just going on and on and on to positive infinity or negative infinity in the x direction. And so what we have here, if we have an even degree polynomial, then our ends go in the same direction. So a positive coefficient, we would say, go up, up. And a negative coefficient, the ends would go down, down. So let's go down here and do a little example. So if I have an even degree polynomial, so the easiest one to think about is going to be y equals x squared. So y equals x squared. So this is an even degree. So this would be 2, 4, 6, 8, any even degree. So if you think about your standard y equals x squared graph, it looks like this, right? So this is just y equals x squared. So what's happening at our end direction, or at our end behavior, clear out here, if this was to keep going to infinity, is that this is going up, up. And that's what this says. We have an even degree, but a positive coefficient. So right now my coefficient here is just 1. So this positive coefficient, this is going to go, or sorry, my coefficient here is just 1. So it's going to go up, up. Now, if I have a negative coefficient, so if I had something that looked like this, let me rewrite this. Y equals negative 2x squared. It doesn't matter that I have a number here and I don't have a number here. What I know is that this is going to open down. And we've always just looked at it like that. It's like, okay, my a value here, or this first value, is negative. So because this is negative, I know that my graph is going to open down. And that's what this says. If our coefficient, so the number that's in front, is negative, then we know in an even degree it opens down, down. Okay, now let's go up here and look at an odd degree. So an odd degree, it's going to be here, what's going to happen are the ends are going to go in opposite directions. So a positive coefficient, we're going to go this direction, and a negative coefficient, we're going to go in this direction. So what I'm going to do, again, is I'm going to tie this back to the easiest function that we know. So I'm going to go over here, and if I have y equals x is odd, because it's technically x to the 1. You could also think about this in terms of y equals x cubed. So I have a positive coefficient. If I was going to graph this parent function, and let's just do x cubed, I would have something that looks like this. So what I have here, I'm going to go up and add to this, a positive coefficient is going to go down, and on the other end, it's going to go up. So here's my x cubed. I have a positive coefficient. If I look at just my normal parent graph, I start going down, and I end going up. So my direction looks like this. Now, if I have something that looks like this, negative x cubed, well, negative x cubed, remember, it means I'm going to flip it over the y-axis. So this one is going to start on the up, and it's going to go to the down. So think about this, opposite line. You know, it doesn't have to be this fancy. You can just think about what happens with negative x. Well, you have a negative slope. So a negative slope is going to go like this. So it's going to start up, but it's going to end down. And what I would tell you is that this whole section here under end behavior is going to be absolutely key to everything in this unit. You've got to just memorize this and know, and we're going to talk about this a lot in class. So even degree, just think about x squared. When that value of that coefficient is positive, we know it opens up. So our end behavior is up, up. When it's negative, we know it opens down, so our end behavior is down, down. When we have an odd degree, so y equals x or y equals x cubed, we know that we are going from left to right. Our slope goes up for this line, so we go from down to up. But when that coefficient that's in front of it's negative, it's like we're saying we have a negative slope, so when we're having a negative slope, we go from up to down. Okay? All right, let's keep going. All right, so what do we have here? What we want to say is that the degree of the polynomial determines the maximum number of turns. We'll talk about what that means in just a minute. And on the graph, the maximum number of zeros, and we know a zero is also an x-intercept. Okay, so if we have a maximum number of turns, so our maximum number of turns is all dependent on the degree. So if I have something that says y equals x, this means I have a degree of 1, so I'm going to have 1 turn. If I have something that says y equals x squared, I'm going to have 2 turns. Okay, now what this tells me is that with this degree, it looks like this. In fact, let me change this up a little bit. So this is actually going to be the degree minus 1. That's how many turns I'm going to have. And so what happens is, if I have a graph that looks like this, I don't turn, right? So because I don't turn on this, it's only going from negative to positive. So we're going to change this down here. I don't have 1 turn, I have 1 0, and that's what I have down here. I have 1 0 on my y equals x graph. So this is just the degree. I didn't look at my words over here. So I have 1 0, it happens right here, and I don't have any turns. So this would be 0 turns. Now let me go over here and look at y equals x squared. So y equals x squared, I go down to up. And when I go down to up, this means I have 1 turn. Now, we look at this one and you're like, okay, but we only have 1 0, but let me rewrite this. So if I have a quadratic or a polynomial that looks like this gives me 2 zeros. So my y equals x squared, this is going to give me 2 zeros. All right, so the degree of your highest polynomial, if we subtract 1, so the degree minus 1 tells us how many times our graph is going to turn, and then the degree itself is going to tell us how many zeros we can have. Like this is actually going to be the maximum number of zeros, right? So we know that if we have a quadratic that looks like this, we have 2 zeros. If we had a quadratic that looks like this, we have 1 0, and I could have a quadratic that looks like this, and I have no zeros. All right, so this is just the maximum number of zeros that we can have. All right, so let's talk about one other thing when we're talking about what a polynomial looks like. So I have 4 examples of a polynomial here. So this is the first one, and this is not a polynomial, and it tells you right here it's not a polynomial because this has a break in the line. So this break means that it is not continuous. All right, here's another one. This is not a polynomial, and the reason is we have 2 things here. We have what could be called a corner or what could be called a cusp. And what a corner and a cusp is it's a sharp turn. So we know one of our parent functions has a corner, and that's our absolute value function. We know that our absolute value function is going to have this corner right here. And that's why it's not a polynomial, because we don't have a degree. So if we look at this, y equals the absolute value of x, there's no degree on this. And so this is not a polynomial because we have this sharp turn. Now this is a polynomial. So this is a polynomial because I have a smooth continuous line. Okay, and this is also a polynomial because I have this smooth continuous line. So let's go back. We were talking about maximum number of turns and maximum number of degrees. So let's count this on this one. So here's a couple things that I know right away. This graph is going to have an even power, and I know that it's an even power because my end behavior is up, up. And if I look at this, I have 1 turn, 2 turns, 3 turns, 4 turns. So this graph is going to have a power that's going to be x to the 4th. It's even, and I know my end behavior is up, up, so what I have here is a positive coefficient. Now, it's not necessarily going to be just x. I could have a number in front of it, like a 5, but this 5 is going to be positive. So if we look at this polynomial, my end behavior goes down to up. So down to up, it's going to look like this. So I know that this has to be odd. And if this is odd, I'm going to have 1, 2, 3, 4, 5 turns. And because I have 5 terms, I know that this is going to be x to the 5th, and any number that I could have in front of that would be a positive number. And I'm just making this number 3 up, or over here this number 5. I'm just making those up to show you that you can have a coefficient in front of those numbers. Okay? So that's why the end behavior is super important, because it's going to tell you if you're an even or odd. And then the number of turns are going to give us our degree. Okay? Now, when we get to zeros, it gets a little bit different based on what's happening at the x-axis. But we can tell a whole lot from just this. Okay? So let's do a little practice right here. So the degree of this polynomial. So first thing you want to always do is make sure that it's in descending order. Make sure that it's written in standard form where your biggest power is first. And this one is. So my degree is going to be 4. My leading coefficient is -1. My leading coefficient is -1. So because of this, the maximum number of zeros I have is going to be 4. And the maximum number of turns that I'm going to have is going to be 4 minus 1, which is 3. And that's what this formula up here was. Remember, maximum number of turns is the degree minus 1. So what I know about this is that because this is a degree of 4, this is going to be even, which is going to give us the same direction. But because this is a negative number, my graph is going to do something in here, and it's going to go down. Now, I know my maximum number of turns in here is going to be 3, so I can actually sketch this, and I would say 1, 2, 3. So it's going to look something like that. And we're going to get into more details on like where we're going to cross and the whole bit, but everything that you need for the shape of the graph comes from these 4 things right here. Okay? So let's look at this one. Descending order, maximum degree would be 3. My leading coefficient is positive, so right away I know that I'm going to have something that has end behavior that looks like this, right? It's positive, so it's going up. So my max number of zeros is going to be 3, and my max number of turns is going to be 2. And so what I know I have on this is going to be something that's going to be 1, 2, 3, something that looks like this. All right? Okay, let's go down here. We've got 2 more. This one, I'm going to look. We are not in standard form. We are not in descending order. So this right here is the term that I care about. That is the term that's my biggest power. So my highest degree is 3. My leading coefficient is a -3/4. So degree is degree is odd. Leading coefficient is negative, so my line has to look like this. Think of it as negative slope. So my maximum zeros is 3, and my maximum turns is 2. So again, I'm going to have something where I'm going to start up here. I'm going to have 1, 2, hold on. 1, 2 turns, and I'm going to go down. Okay. All right. Last one. So I look at my degree. It's going to be this one right here. So this is even. And this is a +5. So I know it's going to look like this. My maximum number of zeros is going to be 6. And my maximum number of turns is going to be 5. So if I start up here, I'm going to have 1, 2, 3, 4, 5. Something that's going to look like that. Okay? All right, so let's go into this next page. And this next page says, what is true about the function's degree and leading coefficients for this graph? So what I know about this graph is that I go from down to up. So I know that this is going to be odd degree, or an odd power. And I'm going to have a positive leading coefficient. I know that right away. What I know about this one is this goes down, down. So if it goes down, down, it's going to be an even degree. And this is going to have a negative leading coefficient, right? Now, I can go even farther than that. I can say I'm going to have 1, 2, 3, 4 turns. So I know that this is going to be a 4th degree polynomial. okay? And with this one, I know I'm going to have 1, 2, 3 turns. So this is going to be a cubic polynomial. All right, so let's get into this graphing. So when we graph this, the degree and the leading coefficient of the polynomial determine the end behavior. Now, I've been showing you this all through this lesson, okay? And so we know that, we've done this, but now we're going to get into the zeros. So when we talk about multiplicity, multiplicity are really going to be our zeros and what happens in the middle of our graph. So if you remember, the end of a graph, what we have here, this down is called our end behavior. What's happening at the very end of our graph? So when we deal with end behavior, we're looking at the degree and the leading coefficient. When we're dealing with multiplicity, we're looking at the zeros and what's happening in the middle. So the number of times a linear factor. Now, when we factor, like factor a quadratic, we end up with something like this, x plus 3, x minus 2. Okay, this is a linear factor, and I know that this is a linear factor because it follows the form mx plus b, y equals mx plus b, okay? And so this is a linear factor. So the number of times a linear factor occurs for a particular polynomial is called the multiplicity. And really, if I could give you a better definition of multiplicity, it's going to be how many times that number is a zero. And it's going to matter because it's going to affect the graph a little bit differently. All right, so for example, we have this graph, x plus 1 to the 5th power and x minus 1. So we have two linear factors. We have the first one is going to be x plus 1, that's this one, and my second factor is going to be x minus 1. So these are my two linear factors. The multiplicity for x plus 1 is going to be 5. And the multiplicity for x minus 1 is going to be 1. I have no power here, so I only have 1. Okay? Now, this is why this matters. So if we have an even multiplicity, then we're going to bounce, and sometimes you're going to hear me say bump. We're going to bounce or we're going to bump off the x-intercept. And this x-intercept is going to be that x value. So here, my x here equals -1, right? On this one, my x equals +1. So remember, we're still going to solve this. We're still going to set this equal and solve it. So this would be x equals -1, and this would be x equals +1. If I have an odd multiplicity, I'm going to pass through the x-intercept, or that x value. All right, so here we go. Let's do a little practice. So we're going to put all of this together. So step 1, find the degree and leading coefficient of the polynomial. All right, so now we have this in factored form. And so if I look at this, I would have one linear factor right here, and I have one linear factor right here, and I have two zeros right here. So my degree of this polynomial is 1, 2, for these two, 3, 4. So my degree would be 4. Now, the leading coefficient gets a little funky here because we have to look at, if I take this x value and I multiply it by this x value and I multiply it by this x value, am I going to have a positive or a negative number? We have to look at what's happening inside the parentheses. We can't just look at the biggest power because when all of this is multiplied out, and if we were to FOIL all this out, multiply it all out, this is not in standard form, okay? So 0.5 times x, times 1 is going to give me a positive leading coefficient. So even and positive tells me I'm going to have an end behavior that's up, up. Okay, oh, sorry, that's what this is, up, up. That's my end behavior. All right, so where do my zeros happen? Well, if this was equal to 0, we know the zeros happen at 0 for this one, and at 2, and at -3. So this is going to be the first thing that I graph. I'm going to have a point here at -3. I'm going to have a point here at 0, and I'm going to have a point here at 2. All right, so I got my zeros from my factored form. Here's what I have. I know my end behavior, so I'm going to start up here, and I'm going to end up here, right? So up, up. Now, remember, when we have a power of 1, when this is multiplicity of 1, it means it passes through. So this, I'm going to change my colors here. This is going to be a multiplicity of 2, this is going to be a multiplicity of 1, and this is going to be a multiplicity of 1. Okay, so if I start here, -3 means I pass through. I'm going to pass through -3. I'm going to turn up. I'm going to bounce off this because this is even. If it's even, I just bounce off or bump off the number. And then I'm going to go pass through and then meet back up with my end behavior. So a lot of stuff is going on here. Okay, I'm going to go through a few of these, and I'm going to just keep talking through them. All right. So what happens here with my degree? I have 1, 2, 3, 4. There's no x here. There's no x, so that is not part of my degree. So my degree is going to be 4. So my leading coefficient. So this is a 1, but it's really 1 squared, which is still 1. And this is a 1 squared, which is still 1. And this is a -3. So my leading coefficient here is going to be negative. So I have even, negative. So my end behavior is going to be down, down. So I go back up here to find my zeros. I don't have to worry about this guy because there's no x. The only thing that this is telling me is that I'm going to be down, down. That's the only thing it's telling me. So I have a 0 here at -1. That's this one. And I have a 0 here at +1. Now right underneath it, I'm going to say this has a multiplicity of 2. That's what this power of 2 tells me. I have 2 of these linear factors. And this also has a multiplicity of 2. So remember, multiplicity of an even number, this is going to be a bump. Bump or a bounce. Okay, so end behavior, I'm going to start down here. I'm going to end down here. I'm going to pass my 2 zeros up here at -1 and +1. Okay, so these are both going to be bumps. So I start at my end behavior. I'm going to bump off this line. I have to turn and bump off this line, and then I come down. And again, we're not worried about where this is right now. We'll get into more specifics. Right now, we're just looking for the shape. That's all we care about. Okay, let's try another one. This is 5, and this is 1. So my degree is going to be 6. So this is a positive x, and this is a positive x, so my leading coefficient has to be positive. So even, positive, is up, up. Now my zeros on this guy are going to be this one, which is -1, and this one, which is +1. Okay, now this tells me that I have a multiplicity of 5. So my -1, I have 5, and my +1, I have 1. Now, what I know is these are odd, so if they're odd, it's just going to pass through. Right? So my end behavior is going to be up, up. I have a 0 at -1. I have a 0 at +1. I'm going to pass through. It doesn't matter that this is a multiplicity of 5 and this is a multiplicity of 1. That doesn't matter at all. So what's going to happen is I'm going to pass through. I have to turn, and I have to pass through. Okay. I want you to pause the video and don't graph these, but I just want you to fill out the charts for these three and then we'll look at them and we'll graph them together. Okay, so I'm going to pause my video too and fill this out and then come back on and we'll graph them together. Okay, I'm going to give you a minute, check yours. All right, so let's go ahead and graph this. So, degree of 5, positive leading coefficient means I'm going to go down up. So I need to graph my zeros first. So I have 1 at -1, I have 0, and I have positive 2, and my end behavior is going to be down up like this. Now, what I see is that my multiplicity for all of these are all odd. Because these are all odd, I'm just going to pass through. So it's going to go like this, and then this, and then this. Okay? So, degree is 3, negative, so I'm going to go from up, down. So up, down. My zeros happen at -3, -1, and positive 2. Oh, I probably didn't make that arrow wide enough. So it's going to go, oh, and they're all multiplicity of 1, so they're all odd. So pass, pass, pass. Okay, last one. I'm going to start down here. I'm going to end up here. It's odd, positive. And I have a 0 at 0 and 1 at 3. Okay, now this 1 at 3 has a multiplicity of 2. So this one's going to be a bump or a bounce. Okay. So I'm going to go through the 1 at 1, and then here I'm going to bounce off this one and go up. So it's just a bounce. I hit that value at 3 and I go back up. I don't cross through it. So at 0 I had a multiplicity of 1, so I just go right on through the line, and then I'm going to bounce, which means I'm going to hit that x-intercept and just turn. So I'm going to bump it and go back up. All right? Last thing here. We want to match the graphs. So I'm going to look at end behavior. So this one is going to be positive, even. So positive, even is going to be up, up. This one is going to be negative, even. So this is going to be down, down. This one is going to be negative, odd. Negative, odd. Think negative slope. And this is going to be positive, odd. Think positive slope. Okay? So if we're matching graphs, this graph has a positive slope, and it's odd, down to up. So number 4 has to be A. This one is even, down, down. So this one has to be B. This one is up, up. So it has to be C. And then this last one is up, down. So negative slope, so this one has to be D right here. Okay, lots and lots of stuff going on. So please come and see me if you want to work through these.